Hello everyone, I welcome you all to this 30 days masterclass series on electric vehicle design. Today is day 5. I welcome participants. I welcome you everyone here. Am I audible? Can you please confirm? Am I audible? Yes. Here participants, am I audible? Can you please confirm? Yes, very good evening. Warm welcome participants. I welcome Rogan, Mohit, Chadamadan. Yes. Yes, thank you participants. Thanks for your comment. Yes. Thank you. So I hope you have all calculated your vehicle dynamics and you have learned something about. Yes, audible. Thank you, participants. So I hope you have learned about vehicle dynamics and the basics of the electric vehicle systems, right? So now this is the model one, so which we have completed for past 4 days. So from today to next 1 week, we are going to discuss in detail about the power electronics, which is widely used in this EV systems, right? So if you talk about electric vehicle systems, then you cannot omit the power electronics. So this is the common topic for everyone. This is the common topic for everyone, right? Just a second. Yes. So are you ready to learn these concepts? Are you ready to learn these concepts? Yes. Thank you. And already we got some delay, so let's directly move to the topic. And this is Malaypan from pantechelearning Private Limited. About Pantech, Pantech is a educational equipments manufacturing company. From Pantech, you can get lab equipments for EEE, ECE, computer science, and IT related products. You can get it. Our vision is to help 10 million students learn the technology in easy way. So far, we have reached about 10 lakh students. And you will get attendance at 7:30 p.m. After that, so in between that live, we will share the attendance form. So please don't forget to submit your attendance form. And this is our 30 days agenda, so you can use it. And is our associate partner is APSSDC. I thank for APSSDC for providing this wonderful opportunity. And recently we signed a MOU to promote to facilitate the free training programs for the engineering and then polytechnic students. And Pantech recruits freshers. So if you are freshers, you can join in the Pantech as a team. To just walk into our website. Just walk into our office, so which is located at Chennai, Hyderabad, and then Coimbatore. Right. So sorry for this delay today. Due to some network issue, I got 10 minutes delay. So immediately we can start the content. So are you ready to learn the power electronic concepts? So if you are ready, please comment in the comment box. Ready to learn. RTL. Just comment in the comment box RTL. Ready to learn. If you are ready to learn the power electronics concepts, so please comment in the comment box ready to learn. Saju Leo. I can't log in my registered email. So you have to use any one of the email ID. So please follow that system. Thank you, participants. I'm very happy to see your replies. So you all are taken a very good step in this in your career. Yes. So if you want to wait, if you want to start the power electronic or electric vehicle technology, then definitely you must know about power electronics, right? So now let's move to the power electronics. What is the power electronics? Do you have any idea about the power electronics? Do you have any idea about the power electronics? What is the power electronics? So the power electronics is a application of solid state electronics to control and conversion of the electrical power. See here, now we have a electrical power in your domestic applications like a 230 voltage, and then if it is a single phase, then it will be a 15 ampere. If it is a three phase, then it will be up to 45 ampere. Again, that depends your load demand. So now you have a one kind of power, 230 voltage AC. But our gadgets, can you just list some examples of your electronic gadgets? Do, can you just comment uh, some electronic gadgets names in the comment box? Yes, just comment in the, yes, just name any one of the electronic gadgets. Yes, thank you, Manya. So can you just comment in the comment box any electronic gadgets? Yes, correct. Mobile, computer, headphones, fan regulator, TV, cell phone, inverter. Yes, computer, of course, speaker, mic. Correct. So these are all the electronic gadgets. So to operate these electronic gadgets, you need some power, right? But available power is only the 230 voltage AC. And nowadays if there is a solar power, then it will be a DC power will be available, but absence of solar you will get only the 230 voltage AC power. So from this one, if you take your computer, what do you know what is the operating voltage of the computer? Do you know what is the operating voltage of the computer? So the operating voltage of the computer will be like 14.6 voltage, and then ampere, again it depends the peripheral. For the main core like Intel ICE processor will work, the top of the voltage will be like 1.8 voltage is the core voltage, and then peripheral voltage will be the 3.3 voltage, and again the IO voltage will be like 5 voltage, right? So this is the operating voltage of the Intel processor. Similarly, in your computer, lot of peripherals are there, right? But the available voltage is 230. Then the required voltages are the so many voltages. So now you need any one of the device or a circuit to convert from fixed voltage to the your required voltage. So that is called the solid state electronics. So the solid state electronics nothing but the combination of semiconductors and the passive components. The combination of semiconductors and then passive components. Here the semiconductors nothing but do you know that mechanical switch? Do you know the mechanical switch? So if you don't know, just see this one. All of us we are using this kind of switches in our wall socket. Just check it in the Google. Switch for, yeah. See here, if you take this switch, so this is the mechanical switch. If you operate the switch, then you may get a connections. So the switch will get connected. Similarly, if it is not, if you switch off the, if you turn off to the switch, then the circuit will get open, right? Similarly, some kind of solid state materials is used for this purpose, to turn off the circuit and then to turn on the circuit. So that is called solid state electronics. So let us discuss one by one. So try to engage with the entire class, right? So now, yes. So here the input power is controlled with the help of solid state switches to get a desired output voltage. To get a desired output voltage. For that, so we are using that controller. So here the controller nothing but it's a pulse width modulated controller. So PWM is the one kind of controller to control the solid state switch, so that the input power will be converted as a output power. So in the previous sessions, we heard the name about the PWM, pulse width modulations, pulse width modulations. So here the PWM is going to control your solid state switches. So that's called solid state switch. Will form as a local circuit. It's a combination of solid state circuits components. So that will convert input power to the output power, right? So this is the basic concepts of the power electronics. So if you take in detail, see here, this is the source. So here, as we have like a 230 voltage. So here we have a 230 voltage input, and this input is going to give you the proper output voltage based on the load demand. Suppose if you take a LED light, so that LED light will work at 12 voltage and then 1 ampere. So you have to form one AC to DC converter. I will tell you what are all the types and then how we can formulate it. You need to form one AC to DC rectifier. So that rectifier will give you 12 voltage with 1 ampere output. Similarly, if you are going to operate, if you are going to control a BLDC motor or induction motor or PMSM motor, then you need a special kind of inverter to get a regulator output voltage. Right? So here you can learn the new concepts of regulations. So whatever it may be the input, we need the desired output voltage. We need the desired output voltage. So that to achieve the desired output voltage, we need a control loop. So that is called the regulations. So the control loop will monitor the output voltage or output power to maintain on its rated value, right? So that's why that part will be taken care by the controller. So here can you just name any one of the controller? Can you just name any one of the controller? Very first basic controller is the 555 IC timer, right? So the timer IC, do you know that a 555 IC, 555 timer? So the 555 timer will work in two modes. One is that astable multivibrator and another one is that monostable multivibrator. So that this astable multivibrator will generate one kind of pulses. So we can use that pulse as a pulse width modulated purpose, PWM purpose. Is it clear? If you understood the concepts, please comment in the comment box. If you understood the concepts, please comment in the comment box. Yes, PID controller, MCU node. Exactly, Mr. Varshini Panastri. Yes. TMS 570. Yes, exactly, Mr. Chetan. Yes. Thank you. 5K resistance in all resistor. Okay, I don't know what you are telling. Thank you. Thank you. Right. So now let's move to the topic. So what are all, how we can control the power electronics? See, for example, if you take a input is a AC input, then output. Now we have to generate a 12 voltage DC output. So here the input is controlled with the help of this PWM. So this is the PWM. So we can call it as a controller. So this is a controller and this is the input, right? And this model, right? So this model is called output. So this model is called the output. So the input is applied and then based on the PWM position, we are getting the output voltage. So now you are getting the option to control the input voltage. So now you are getting the option to control the output voltage, not input, output voltage. So anyway, we are going to utilize that output voltage only to the load, right? So so now yes. So this is the ideal switch. So as we discussed in the earlier. So if you operate the switch to downside, then which means that this switch is connected. This circuit is connected to the positive to negative. Similarly, if you take any one of the SCR, MOSFET, IGBT, so these are all the basic power electronic or solid state devices, so which is widely used for the power electronic applications. So this MOSFET or this IC will I mean, whenever you are applying the PWM, so whenever you are applying the PWM at the time of starting instant, the MOSFET will get connected. Otherwise, it will not get connected. Right. So now we are getting a controlling features by by providing the PWM pulses to the circuit. By providing the PWM pulses to the circuit. Right. So simple for understanding purpose. So this switch is equal to the MOSFETs or IGBT. So here we can call it as a mechanical switch. So here we can call it as a solid state switch. Here we can call it as a solid state switch. And here again one more thing. So ideal switch and then practical switch. In the ideal switch, definitely whenever you turn on the MOSFET, then it will directly the circuit will get connected at the instant. The same instant will get connected. Whereas in the practical case, it will not be there. So there will be a transient states. There will be a transient states. In the ideal case, whenever you apply a PWM, then immediately the MOSFET will get turned on. In the practical case, it will not be. In the practical case, it will not be. So it will take some time. So that is called the transient states. Those concepts and we will discuss in detail in the forthcoming classes. So I will tell you what is the zero voltage switching, what is the zero current switching, everything we will discuss in detail. And also I scheduled how to design the gate driver circuit for this kind of MOSFETs, IGBTs and then SCRs. I have a special session for you. So please don't skip the session. Right? And see here, so this is the working principle of the MOSFETs or IGBT. This is the common working principle for everyone. If you take a diode, if you take a SCR or MOSFETs or IGBT, so inside the device, so when you try to improve the increase the gate voltage, so if if this voltage is increased, then what it will happen? So this is called the drain to source voltage. So this is called the drain to source voltage. Yes. So here we are trying to apply the PWM, and here this current flow will be like this. So here the current flow will be like this. When the gate voltage is 0, then there will be a depletion layer. So the depletion layer will disconnect the circuit. So whenever the depletion layer vanishes, then the connection will get established. So in that case, the drain and then source will get connected. So in that situation, the source will be transferred to the load. Then we can change the current flow path with the help of the combination of these circuits, right? So now the types of power converters. So here the types of very first one is called AC to DC rectifier. So can you just name the example of this AC to DC rectifier? Can you just comment in any one of the name for the rectifier? Can you just comment in the comment box? Just name any one of the just name example for this in rectifier. Where we are using this rectifier? Yes. So in the power supplies, we are using this rectifier. Generally, if you take a mobile, in your mobile, the first part will be the AC to DC rectifier, because you are connecting your mobile to the 230 voltage power supply. So in your mobile adapter, the first part, there are a lot of power stage conversions are there. So first part will be a AC to DC rectifier, right? And next one is called chopper or DC to DC converter. So this is the very first topology, and this is the second topology, DC to DC converter, right? And see here, another one is called the inverter. Another one is called the inverter. So this voltage will be the DC to AC, and one more type of converter also there called AC to AC. So generally we are not using that concepts in this EV applications. That's why I have not included in this session. But similarly, we have in Pantech you have a MATLAB Simulink for electrical engineering, and then solar and renewable energy power system design. So in those concepts we have included AC to AC concepts also. If you are interested, you can visit our website. So you will get to know about more in about those informations. right? So here how all are interconnected in the sense, suppose if you take your mobile charger, so the mobile charger, do you know what is the operating voltage of your mobile? Can you just confirm in the comment box, what is the operating voltage of your mobile? What is the operating voltage of mobile? Yes, can you just confirm in the comment box? Yes. So likely it will be like a 5 voltage or 4.5 voltage is the operating voltages. So for your mobile, right? See here. So let us take this is the exactly you need the 5 voltage. Exactly you need a 5 voltage, right? So there should not be a I mean point not one voltage ripple also it should not be available. So it must be a exactly 5 voltage. Whereas the AC to DC rectifier, so here so here so the input voltage will be AC and here the output voltage will be DC, like this it will be. And again if you apply a filter, then it will be a like a so voltages. So generally this rectifier will have a huge voltage ripples in the output side. So generally the rectifier will have a huge voltage ripple in the output side. So to avoid that ripple in the output side, so we are using the DC to DC converter or chopper, right? So if you apply the same voltage at here, then we can get a pure DC voltage. So in your mobile, there will be two-stage power conversion. The very first conversion is called AC to DC uncontrolled rectifier or controlled rectifier, whatever it may be, it will be available. And after that, small DC to DC converter will be there. So that converter will give you the proper 5 voltage, 0% ripple output will be there, right? So this is the basic difference and why we are going for this DC to DC converter focus. And so this DC to DC converter is widely used for various applications. Wherever you want to design your power supply, then you have to use this kind of converters. And the types of DC to DC converters are many types are there. We will discuss in the DC to DC converter sections, and how to choose the power converter, where we are using those converters for our EV applications. Everything I have scheduled in this session. So please try to engage with the entire class. Try to engage with the entire class. And types like a buck converter, boost converter, flyback converter, push pull converter, how to choose your converter based on the rating. So we will discuss in detail, right? And similarly, the next model is called inverter. See here, this inverter is converting DC to AC. Why we have to convert DC to AC? So already we have a AC, but again why you need DC to convert? Why you want to convert from AC to DC, again DC to DC, and again DC to AC? So because these types of converters are widely used for various different applications. If you want to control your induction motor, if you want to control your induction motor, so you need a controlled voltage and then controlled frequency. So that is the speed control methods. So this inverter will help you to control your output voltage and then your output frequency. So for that applications we will use that inverter. If you want to control your motor, then you need this inverter, except a BMDC motor. Except a BMDC, we need an inverter for a BLDC motor and then PMSM motor, induction motor, and for SRM it's a typical different topology. Right. So again, I have included all the motor control part in this session. So please try to engage with the entire 30-day class. So where this powertronic converters are used in these applications? Can you just comment in the comment box? What is the where we are using powertronic converters in the EV applications? Where we are using this powertronic converters? Can you just confirm me? Can you just comment in the comment box? Very first application is very first application is charging stations. So here the charging stations. Yes, Mr. Ganeshwar. Thank you for your reply. Thank you for your reply. Yes, in the charging stations. So very first one, the charging station. Second one, onboard charger. So the onboard OBC model will have a powertronic converter, and similarly the inverter model. So we can call it as an inverter drive or a powertrain inverter, whatever it may be. So the inverter, in the inverter model, there will be a powertronic circuit. Similarly, the power supplies, because the more electric vehicle has a lot of electronic gadgets like infotainment and then cruise control and then power enabled windows, sliding doors, and your seats and then dashboards, everything we need additional systems. So for that one we need a various power supplies. So generally these are all the major four areas we are using the power converters, right? Yes. Yes, Tejas, I will share you the attendance now. Please wait. I will share you the. I will ask my team to share the attendance form. Just concentrate on the class. And similarly, can you know what are all the typical voltage range of the converters? Just comment in the comment box. So what are all the ratings of the power converters? Can you just comment in the comment box? Yes. Dear participants, please wait. Attendance form will be shared shortly. So please don't rush up. I will share you the attendance form. I will share you the attendance form. Please don't rush up. I will give you the attendance link shortly. Right. So the OBC nothing but onboard charger. OBC nothing but onboard charger. Yes, you can get all the notes from the internship portal. 5, 12, 24. Yes, some of the EV cars comes up with for 600 voltage DC operating voltage also, and 48 voltage, 72 voltage. So these are the voltage ratings. So again, the power rating depends the power current rating depends the power, it will widely will change. And the charging stations again. There are the few types are there. So to understand all those concepts, you must know what are all the working principles of the solid state switches, right? So first let us understand what is the diode. So the diode is a solid state device. So whenever it is the forward bias, then the circuit will get connected. See, for example, so basic example. So this is the diode example. So now we are getting the anode and then cathode. Suppose if you apply a voltage positive at here and then connected to the negative, then the diode will get connected. Suppose if you are connecting negative here and then positive here, what it will happen? So this diode will not get connected. So it will get open circuited. Simple understanding purpose. If the diode is in the forward bias, it will get connected. If it is in reverse bias, then it will not connect. It will be open circuit. So here the SCR also the similar conditions, but you have one more control called triggering mode. So whenever even though if it is a forward bias, it won't conduct. So whenever the PWM applied on the gate pulse, then only the diode, the SCR will get connected. So that is the main difference between the diode and the SCR. Yes, dear participants, please attend the class. I will share you the attendance form. So please don't rush up, Mr. 420. I will remove it from the class. If you want attendance, please come later for the after the class alone. Please don't rush up and then don't spam the chat. Attendance form will be provided shortly. And similarly, the MOSFET again, this is the another kind of solid state switch. So the operating principle is everything same. The operating principle is everything is same. like whenever the PWM applied, then the either anode to cathode or drain to source or collector to emitter will get connected. Otherwise, it will not get connected, right? So now, and how to use the how to choose the devices for rectifier. So here we will use the components as a SCR, and whereas for the chopper we will use MOSFET or IGBT, right? MOSFETs are IGBT, and similarly for the inverter we will use the same thing. So here, how to choose the device and all, you first you should identify your operating voltage and then switching frequency. So, but for majority of the applications for rectifier like uncontrolled rectifier or basic controlled rectifiers, we will use a SCR or diode for uncontrolled purpose. Similarly, for the chopper and then inverter, we will use MOSFETs or IGBT. Other than this, lot of devices also there like GAN devices and GTO, SiC MOSFETs and GAN devices. Everything is there, right? So these are all the applications widely used in the electric vehicle. So bidirectional converter, battery charging applications, and direct conversions, resonant converter for the bidirectional, isolated bidirectional converters, multi-level two quadrant converters. So in the Pantech, you will get research assistance according, on these topics also. So if you want to get a customized power prototype solutions, you can approach us. We will help you, right? And what is the rectifier? See here, generally the rectifier is called as a controlled rectifier and then uncontrolled rectifier, right? So what do you mean by controlled as well as that uncontrolled rectifier? So the controlled rectifier will give you the output voltage as a controlled manner, whereas the uncontrolled rectifier will use a basic diode. Whatever you are applying the input, so the entire input will be converted as a DC and it will give you the output voltage. And then types of the converters, again you will get a half wave, full wave, and then single phase, full three phase, semi converter, full converter, everything. So this type of rectifier is common for controlled as well as the uncontrolled. So in the uncontrolled rectifier we will use a diode, and whereas the controlled rectifier will use a MOSFETs, sorry, SCRs, right? So let us move to the yes. So before, if you want to understand the working principle of the power electronic concepts, so you must know what is the waveform analysis. So if you take a sine wave, see here the entire period. So this is the starting period and this is the end period. So here from starting to end, so the entire period we can call it as a frequency, right? So if you take a 50 hertz as a frequency, then the time period is 1 by f. So we can call it as a 20. We can take it as a 20 milliseconds. We can take a 20 milliseconds. So this 20 milliseconds is equal to 360 degree. So 360 degree. So 20 milliseconds are equal to 360 degree. So which is one cycle. So can you just comment what is the time period for the 1 degree? Can you just comment what is the time period for the 1 degree? So the 360 degree is equal to 20 milliseconds. And what is the time period for 1 degree? What is the time period for 1 degree? Can you just comment in the comment box? What is the time period for the 1 degree? Yes. Can you just comment in the comment box? What is the time period for 1 degree? So 1 degree, 360 seconds. Oh, exactly, you must tell. Exactly, you must tell. So, 20 milliseconds is equal to 360 degree. So, what is the time period for? Yes, Mr. Rakesh, you are correct, absolutely correct. 0.055 milliseconds. So that is the one time period for 1 degree, right? So how you can calculate it? So just open the MATLAB. So 360 degree is equal to 20 milliseconds, right? So 20 e power minus 3. So now 360, yes. So 1 degree is 20 e power minus 3 divided by 360. So 5.55 e power minus 5. So this is the time period for 1 degree. This is the time period for 1 degree. Is it clear? Is it clear? Can you just comment? Yes. Yes, Mohammed. Thank you, Gautam. Thank you, Naresh. Yes. Thank you, Sudhakar. Thank you, Mohammed. Thank you, Sai Sundar. Thank yes. 20 milliseconds divided by 360. So that is called a time period for 1 degree. Right? So attendance link, I will share it. Yes, I will share the attendance. So please wait. I will make it in the top of the chat. Yes, I shared in the top of the chat. You can define. Right. So now let's again move to the topic and see here half of the cycle will be the 10 milliseconds and then the full cycle will be the 20 milliseconds, and similarly the maximum voltage, so the peak amplitude, so this will be the A max. If you take a sine amplitude is 1, then the maximum value, then the RMS value will be PM divided by root 2, so that is called value about 7.707. And for the average voltage will be 67%, 63.7% is the average voltage. So that is applicable for the DC powers applications. I hope you have understood the sine wave analysis. So the frequency is the F, then the time period for the F, one single cycle is that 1 by F, so which is 20 milliseconds for the 50 hertz, and then peak value is Vm, maximum voltage, and then RMS voltage will be a peak divided by root 2. So peak divided by root 2. So that is RMS voltage. So now let's move to the calculations. Again, we have already calculated. So 20 milliseconds. So 1 degree is equal to 20 milliseconds will be 360 degrees. So this is the 5.55 e power minus 5. So now let's move to the example. So this is the AC rectifier. Yes. Yes, I will tell you one by one. And the rectifier, AC rectifier, see here, here we are applying the input voltage AC, and this is a diode. So diode is a two-terminal device. As already I mentioned, diode is a just a solid state device. Whenever it is the forward bias, then it will conduct. If it is a reverse bias, then it will not conduct. So during the positive cycle, so the diode will be in the forward bias. Diode will be in the forward bias, then it will get connected. So due to that conductions, then we are getting the output voltage at the positive alone. Similarly, for the negative period, then it will not be a forward bias, right? So it will be a reverse bias. So due to that reverse bias, then the output voltage will be 0. So due to that principle, we are not getting the output voltage. So since it's a half wave rectifier, we are getting the output voltage only on the positive side. So for the negative period, we are not getting the output voltage, right? Similarly, if you take a full rectifier, so we may get a output voltage will be a always you will get output voltage, because so this four diodes will give you the alternative current flow path. For example, for the positive diode, positive waveform or positive cycle, we will call it the D1, and then load, and then D4 will get connected. Similarly, for the reverse bias, D3 and load and D2. So this is the return path. So at any point of time, the load will always will get a DC voltage, right? So due to this working principle, we are getting the output voltage always. Is it clear? Is it clear? If you understood the concepts, please comment in the comment box. So one diode is the half wave rectifier, and then 4 diode will be the full bridge rectifier, full wave rectifier. Yes, thank you participants. Thank you Ashwini. Thank you Divakar. Thank you Rahul. Thank you Mahesh. Yes, thank you Mohammed. Super. Thank you. I'm really happy when you see your replies. Yes. Not so clear, Sharvesh. What is your doubt? So just comment in this video comment box. I will give you the answers. Yes, Harsha Rana. Of course, people will have different requirement, different commitment. Let us check. Let us hope this 580 people can extend that can will be available for next 30 days. Thank you, Dr. Kamal. Shashank, no, Nikos. See here, so this four diodes will help us to get output voltage always. So the red color denotes that positive voltage, and then blue color line denotes that negative half cycle. So always you will get a positive voltage on the load side, right? So now let us try to simulate the same in the MATLAB so that you can easily understand the concepts, right? So I'm going to open the Simulink just to create a block. Just create the new block or new work area. So just to take any one AC source and then connect one DC diode and connect one load as a R or a RL, whatever you want, you can connect. Yes. So because all these concepts we are going to use in our EV applications. So if you want to enter into the EV, so definitely you must know the EV concepts. Otherwise, you cannot get the complete idea, right? So just open the library browser. Just open the library browser, and so the power electronic concepts components will be available on the Simscape. So open the Simscape and go to electrical. So here you will get a specialized power systems, right? So here the fundamental blocks. So you can get sources. So first electrical source. So take AC voltage source, AC current source. So just to try to work with the AC voltage source so that you can easily understand the concepts. Then you can go for the AC current source. Yes, thank you, Vinay. So I'm just selected one AC source. So I'm configuring this AC source for our applications. So the peak amplitude always will be 230 into square root 2, and then frequency 50 Hz. So which means that if you are up in your home, it will be a 230 voltage. So the peak amplitude will be 230 into root 2. That's it. So this is the voltage source configurations. And now we need a diode block. So again go to the same locations and select the power electronics. So here you may get a different type of components. All the components will be available. Just select it. So now I'm just connecting. We need to measure the input and then output voltage as well as the current, right? So again, go to the same one. Take a measurement, voltage measurement as well as the current measurement. Take any one of this voltage and then current. And again we need a resistance, right? So just select the elements. So here you will get a series inductance, series RLC series branch as well as the load. So if you are sure about your converter load, then you can take it as a load. You have to configure in the terms of kilowatt. If you don't know the load or converter power range, you can use the series RLC load. So just to select it and rotate the component. Just rotate the component and open the parameter. Take R alone, and here I am going to use 230 voltage and the load current will be 5 ampere. This is that resistance value, right? So just to take this one. Yes, I have connected, and so just I am connecting, trying to connect all these things. Yes. So this is the input voltage and this is the output voltage. So if you want to see the block name, I will enable it so that you can use it for your reference purpose. Block name. Yes. So this is the diode and this is the voltage measurement block. Voltage mean this is that source format. This is the current measurement block. And now we are going to connect that source. Okay. So source, sorry, scope. So where the scope will be available in the Simulink in the library. So you may get a scope. Just select the scope and then drag inward. Practice this experiment parallelly so that you can easily learn the MATLAB concepts. Yes, thank you, Divya Srinivas. I'm going to measure the three values: input voltage, output voltage, and then output current. So I need the three scopes. So layout also I'm going to select it, and now I can get a three scope. And similarly, I'm just changing the scope style and just change it as per your wish. And similarly the second graph and the third graph. Yes. So now so input voltage and this is the output voltage and this is the output current. So for this circuit, input current and then output current will be a same, right? So now we have configured everything, and so this again here now we have to add one more important component. So we can call it as a power guide. So which means that it's a similar it's a library header file. So since all these Simulink block sets comes under the power system block sets, so now we have to configure so as a power guide block. So just search power guide here. Yes. So the power guide block just included. So this is the like a header file. I'm just enabling the name. So power guide block. And in the power guide block, you have three different type of simulations: continuous simulation, discrete simulation, and then phasor simulations. See, actually, the continuous simulations will give you the proper output when your system is in the physical systems. So I will tell you one by one. While you involving or while you practicing these experiments, you can realize what I am trying to convey to you, right? Similarly, for the discrete, wherever the sample times are required, so if you want to calculate the accurate timing and all, then you need a discrete simulation type. And then phasor simulation, so that is only for the power system applications. We will use the phasor simulations. So this is not a power system applications. Wherever the large type of ratings will be involved. So in that situation, we will use the phasor type. So for the entire power electronic applications, we can use the discrete type. I'm going to select it here. I can adjust the sample time. So based on the calculations, the program will get run. And now I am going to run the simulation for 1 second. Now I am going to run the simulation for 1 second. Just to save the simulation. Just to save the simulation. P5. Yes. Sorry, this simulation will get definitely will get stuck. So please bear this delay. I'm just running this one. And for the internship people, you can connect me via my WhatsApp number. So tomorrow I will respond you, not today. So tomorrow I will respond you. Yes. So I have connect. I mean, I have some. I run the simulations. So simulation has been started. Yes. So it's run and I generated the result. So now, yeah. So this is the input and then output responses. Let us check. So the input voltage we have applied to the circuit, and then this is the output voltage. So this voltage is across the load, and this is the current. This is the current. So just take 230 is the 230 is the our RMS voltage, but we have applied 325 voltage. That is the peak voltage. So when you apply this voltage, then only you can get a 230 voltage. Similarly, we are getting the output voltage at during the positive cycle alone. For the negative cycle, there is no any output voltage. Is it clear? So now you can convert this as a a full bridge circuit. Take output, share the output in our Facebook VIP group. Right? I will share in the Facebook group. Yes, our EV group are there. So I will share it. So just post your query. Just post your answers. Right? Just a second. I will share my group link. So this is the group name. So you please post your queries. Sorry, post your answers in this one. Thank you, Manur. Thank you, Mayur. So you please post your answers in this group so that we can create others also can learn lot. Is it clear? AC current versus AC voltage source in the MATLAB. Thank you, Mayur Bahawat. Thank you, Vashant Kesami. Thank you. Murali Krishna, we can create a same using the switch block also. Yeah, with the conditioning also. But switch is again in the MATLAB they are giving you for the logical reasons. For the logical reasons. Can you please give my example? What is the your example, Manu? I don't know what is 360. Power guide block is a header file. So in your all the programming language, you need a header file, right? So this is like a header file. Thank you, participants. Thank you, Gramna. Thank you, Shahil. Thank you, Jimil. Yes. So now, I request you everyone, please convert this experiment as a full bridge converter and then take output and share this output in the Facebook group. I have shared the group, so just join this group and you can enjoy a lot. Yeah, I will approve it immediately. So just a second, I will approve the members. Yes, I have approved everyone. So please join and then share your output. So don't post unwanted content. If you practice your output, please share the output in the common this group. Right? Yes, I have approved everything, everyone. So please join this one. I hope you have understood the concepts. So still more, I have I have prepared a lot of examples. So now you have to. So I will tell you, I will teach you how to generate the PWM for the control rectifier in the tomorrow class. So till that, please practice before comes into the next class. Right? I will tell you how to operate all these things, and we will see you in the next class. Root mean square is RMS value. I will give you the WhatsApp group link shortly. And 1 month internship is available on the electric vehicle system design. See here I have modeled, this is the model 1 and this is the model 2, right? So here you can get up to motor control and all. So this is the battery sections, and after that vehicle dynamics. So here and common hardware topics, and finally we will go for the hardware prototyping. So the like this I have prepared for the 30 days. So you just follow this 30 days, then definitely you can learn a lot of concepts. Name of the group EV vibes. New group I will share you. I will share you the new group, so please wait. Yes. Yes, this is the WhatsApp group. Please join if you want. This is the WhatsApp group. I think 29 also. Yes. So just click here. The internship has been extended till today night. So you can join and then you can use this as a coupon code. Welcome EV. Welcome EV. Right. So tomorrow you will get the internship users. You will get an email as well as WhatsApp link by tomorrow of all the students. Now you can ask your questions. EVMC20. Yes, I will share you EVMC20. SRM full form, switch reluctance motor. Switched reluctance motor. The telegram also I have given. PMSM is a sensorless control. Actually, in this section, I have planned sensor oriented, and I am going to work for the FOC control. All the sensorless methods also I am going to release it shortly. Mr. Lenin, use any one of your email and then just apply the attendance form, so which is available on the top of the chat. So please submit your attendance form. So whenever you submit the attendance form, immediately you will get a email acknowledgement. RMS is a root mean square value, which means that if you take a multimeter, then if you connect the multimeter into your wall socket, then it will shows you 230 voltage. So that is called RMS voltage. Similarly, if you connect a CRO or DSO to your wall socket, then it will shows you the waveform. So the waveform will rotate from positive peak to negative peak. So we cannot, if you take average, then there will be voltage will be zero, right? So, but actually it will not be like that. So that is called the peak voltage. AC current source in MATLAB, what happened? That is again, it's a current source applications. If you take a battery or if you take a fuel cell, so those all comes up with current source methods. So you can configure as a current source, ideal source. Bridge rectifier in EV. Thank you, Shanket. Thank you, Patrick. How do I add power electronics in MATLAB? You no need to add. If you install the Simulink, automatically this block will get connected. See here, this block will be available. Simscape, and then go to the electrical and go to specialized power systems. So here you can get all the components. Again, you have to choose the application first. You have to choose the application first. So then only you can use the current source or voltage source. Please reply to the call. Gaurav Mystery. Yes, please call me tomorrow. So actually, since it's today Sunday, I didn't attend any call. Resistor can be called as a semiconductor. No, it's a passive element. It's a passive element. What is GTO? GTO is a get turned off device. So since again this is a one kind of solid state switch. Attendance link is in the top of the chat. How much GB of the software? So the GB, I hope it will take a 20 GB. To give you the class link via the WhatsApp. So that's why we have so many groups. So I will share you the another group. And similarly, I will give you the another group. 7. This is another group. You can join here. Yeah, many difference will be there between 2019 A and then B. No, today attendance only we have given. Today attendance only we have given. So that is a day 5 attendance. So you don't get confused. Yes, participants, thank you for your valuable time, and just have a great weekend, and then we will meet you by tomorrow. If you have any more doubt, so please ask me in this video comment box. I will give you the answers. EV technology will rule the future. Yes, of course, there is no any doubt. Yes, Jadhav, you have to purchase the MATLAB. Thank you, friends. Thank you for your valuable time. And since it's a Sunday, so people are highly interested. So really, I'm very happy to see this. Still, the people and 200 people are there. So definitely, I hope I will deliver my best. I respect your time. Thank you. Thank you once again. So if you have any more doubt, so you can send your questions in this video comment box. I will give you the answers. Take my number. So this is my number 98409 74408. You can use it for your. Thank you. Thanks for your